Now when we get into finding the area of a prism, you have to be very careful to read the problem to find out what area are they talking about. There are a few different areas that they can be asking. They may ask for the lateral area. That is the area around all the lateral faces. They might ask for the area of the bases, the base area. Now remember, all the lateral faces are rectangles. The base area, the formula that you'll use for the area of a base will depend on its shape. So you might use the area of a rectangle or the area of a triangle or the area of a regular polygon, depending on what shape, what polygon the base is. That's the formula for area that you'll have to use. And remember that there are always two bases. Or they may ask for the total surface area. So lateral area is the area around the outside, the base area, the area of the two bases, and then the total surface area, you would add them both. So here we're asking about lateral area. The lateral area is denoted by an uppercase L. The lateral area of a prism is the sum of all the areas of the lateral faces. And remember, your lateral faces are always rectangles. So the area of a rectangle is base times height. The length of your base times the length of your height. So how would we find the lateral surface area of a right triangular prism? So we would have the area of this rectangle, and then we would add the area of this rectangle, and then we would add the area of the rectangle that's in the back, that is the same shape. All three faces have the same area. So really, our lateral surface area is A times the height plus B times the height plus C times the height. If you factored out the height, really what you're finding is the lateral surface area is always going to be the height of the prism times the perimeter of the base, the perimeter of the polygon. So the lateral surface area is always the height times the perimeter. If it's a triangle, you're going to add up all three sides of the base. If it's a pentagon, you're going to add up all 5 sides of the base. So P is the perimeter of the base. That's how you're going to find lateral surface area. That's the surface area of just the outside. So this formula, lateral surface area is equal to the height times the perimeter, is good for finding the lateral area of any right prism. We can also use that for an oblique prism, but we're not going to see any of those here. So the lateral surface area is the height times the perimeter. Now, what if we wanted the total surface area, or the total area, the total surface area? We would need, and total surface area is going to be T. So the total area, also called the total surface area, is going to be the lateral surface area plus 2 times, because we have 2 bases, 2 times the base area. So if you're asked for the total surface area, you have to find the area around the outside, and then you have to find the area of the 2 bases, and then add them together, and that would be the total surface area of a prism. All right, so let's practice that. The total area of any prism will always be the lateral surface area plus 2 times the area of the base. So let's say my base was a square. So the total surface area is going to be the lateral surface area. That's the height times the perimeter. What's the perimeter of a square? 4 times the side. We add up all 4 sides, and all 4 sides are the same length. Plus 2 times, what's the area of a square? Side squared. That's why it's so important to be able to find the area of polygons, because they're going to be used to find the area of prisms and pyramids and cones if you've got a circle for a base, and cylinders. So remember Heron's formula. If the base is a triangular, if the base is a triangle, if it's a triangular prism, remember we can find the area of a triangle is the square root of the semiperimeter, semiperimeter minus one side times semiperimeter minus the second side times semiperimeter minus the third side. So let's continue. Our bases, the bases that we're going to consider, they may be triangles, because we have Heron's formula to find the area of a triangle. They might be squares, because we know how to find the area of a square. They might be rectangles, because we know how to find the area of a rectangle. Could be a rhombus, because we know how to find the area of a rhombus. I've never seen one, but it would be fun to have a kite as the area, as the base of a prism. But also we can have regular polygons. Okay, so a regular pentagon, a regular hexagon, a regular octagon. Remember, a regular polygon, all the sides are congruent and all the internal angles are congruent. So let's talk about some specific types of prisms. A cube is a right square prism. That means that the bases are squares, which means their sides are congruent. And a cube, the edges are going to have the same length as the edges of the square. So if my square in my base is 3 inches by 3 inches, the height of my cube is also going to be 3 inches. And a cube is an important unit in determining the volume of a solid, because a 1 by 1 by 1 is 1 cubic unit. If they were 1 inch by 1 inch by 1 inch, that would be 1 cubic inch. And cubic units are what we're going to use our measures for finding volume.